I just wanted to kind of address a few things that seem to be popping up in the media there recently. A lot of people will be familiar with this thing that came up in the Irish Times, and in it, he just laid out all these facts about some statistics in relation to COVID, the median age, the size of the death rate, and all these kind of things. And to be clear, all these facts are 100% accurate. Like he mentions the median age, he mentions the low number of deaths that we get each week in relation to COVID. He compares it to things like car accidents. He compares it to heart or cancer, to strokes, and all that kind of thing. And basically, all his stats are perfectly accurate, but his conclusion is that the lockdown that's being imposed at the moment is completely disproportionate to what's actually happening with COVID, right? So he just doesn't, and there was a similar one now today in the Examiner, where, again, he highlights all these low numbers in relation to cases, deaths, and ICU cases, hospitalizations. And he comes to the same conclusion that we really shouldn't be, locking down the country just for these low number of deaths. Now, what I want to do there is just use a bit of Leaving Cert Maths to just kind of clarify why we actually should be worried about those numbers, small as they are. So if you take this formula here, and Leaving Cert Maths students will be aware that this is the formula for a geometric sequence, right? So for example, geometric sequence is like, say, if you start at 10, double that to give you 20, double that to give you 40, double that to give you 80, 160, 3, whatever it is, etc. That's a geometric sequence, right? And in that case, this formula helps us work with that geometric sequence. For example, the A stands for the initial value, so that's 10, and R in that case is going to be 2, because we're doubling the number each time, so that's 2. Now, how does that relate to COVID? Well, A again stands for your initial cases, and R in this case is the famous R number that you keep hearing about. Now, the R number is a hard one to explain, but scientists and epidemiologists kind of think that the natural R number for a COVID is about between 3 and 4, right? So, for example, I'm going to change that to 3 just to be conservative. So, what that means is that if you have 10 people with COVID and they just take no precautions at all, then each of these people is likely to infect 3 people. So 10 of these people by week 2 is going to infect 30 people. These 30 people then will infect 3 people each, so that'll be 90 people. And as you can see, that increases exponentially as we go. So that's essentially what the R number is. Now, at the moment, our R number is estimated to be between about 1.2 and 1.3. Right, so, and some people would say it's even higher. So let's stick with 1.2 there for now. So that means that these 10 people, they are now going to infect, by next week, they're going to have 12 people. By the week after that, there'll be 14.4 people, etc. Okay, so the great thing now is that we can actually plot this now on a graph. Right, so let's just have a look at this graph, just to see what happens as the weeks go by. And if you think back to June, this is what we roughly had. We roughly had about, like, the virus was almost eliminated. We had double digits as how many COVID tests we were getting each time. But as we all know, as the weeks went by then, the numbers started very, very, very slowly increasing. Okay, and that leads us on to where we are today. So each of these are weeks down here, and that leads us on to where we are today, where we had roughly an average of about 1,000 cases, okay, each day. Right, so that's where we are now. Now, the people who are doing those articles, their argument is that we really shouldn't be worrying at all about these numbers, because if you take hospitalizations are about 1/10 of that. Okay, so let's do a graph for that. So about 1/10 of this number will end up in hospital. And actually, it's not this number, because this is the known number of cases. The actual number of cases is about double that, and 10% of that then is this number. So here's our hospital cases, and like, this is just from a model that I made up, but that's actually quite accurate. At the moment, we have about 240 cases in hospital, and even more important than that then is ICU cases. So about 1/10 of this then, 10 people who are in hospital end up in ICU. Again, that's about right? 22.9, well, it's actually a bit more than that. There's about 30 people in hospital, in ICU at the moment, in relation to COVID cases. So that's what the lad's argument is that we don't really need to be worried about this at all, because hospitalizations, and more importantly than that, ICU cases are way lower than that. And more importantly than that, the deaths are about 10% of this. Okay, so that's where the deaths are nearly in single figures. Right, now, so what do we have to worry about? Well, the big number that we do need to worry about is this line here. Okay, now this line here represents our ICU capacity. Right, so that's about 282 ICU beds that we have. And the last thing that we need is for this point and this curve to meet this line. Okay, now let's just go on a few weeks and see what happens, or when does that actually happen. Right, so if we carry on the weeks, and if we keep going at the rate we're going, then we will reach that at about week 41. Okay, now that's about, so between now and then, that's about 3 months away. Okay, and that's if we keep going at this rate, then we will reach ICU capacity at this point. Now the problem then is what happens when we hit this. Now at the moment, ICU is doing wonders for people with COVID, and as I said, only about 10% of these people actually end up dying, which is why the numbers are so low. Whereas if we hit this, and if any of these people need to go into ICU and there's no space for them, then a much bigger proportion of these people will end up dying. Okay, and they'll have to be sent home and there won't be space for them. And that's what happened in Italy. That's what happened in Spain. That's what's currently happening in places like Peru at the moment, where they have no space in their ICU and they literally have to send people away to die at home. And you know, that's obviously, I don't think anyone could argue that that's an acceptable thing to happen. Now, you might be thinking, well, that's 3 months away. Why are we getting so worried about that? Right? It's 3 months away. Anything can happen, and if it's still increasing in 2 months, then we can do something. But the problem is, all of this is assuming that the R number is 1.2. Whereas, as I said, some people kind of think that the R number is actually about 1.3 or 1.4 even. And what happens if we start letting our guard down and start forgetting about everything, and that goes up closer and closer to its natural R number? Well, let's just have a look at what happens when the R number increases. So it's 1.2, 1.25, and importantly, keep an eye on what is happening to this point. So the higher the R number goes, the closer we get to reaching ICU capacity. So this is 1.3. So if the R number is 1.3, or if it becomes 1.3, that means that our ICU capacity is very, very close altogether. Okay, so that is what we need to be worrying about. Now, I'll finish on a kind of a high note. So let's say we reset this and we start at week 1, but at the moment we have 1,000 cases. Right, so this is 1,000 cases, week 1. Don't worry about the curves now just yet. But what happens if we bring this R number down? Right, and we're all about talking about bringing the R number below 1, because what happens then? Below 1, just focus on the blue line now. Once it goes below 1, then the numbers start increasing. Okay, so that's just barely below 1. But what if we bring it down to 0.8? When we bring it down to 0.9 even, that's when the numbers start really decreasing. We can forget about all of these things, because as this starts decreasing, these really start decreasing, and eventually you get to a stage where it goes away if you can keep it at 0.9. So I said I'd finish on a high note there, and that is COVID explained with Leaving Cert Maths.